I'm going to walk through number 1 with you. This is on the nonlinear piecewise function. So you need to have this sheet out. Everybody get it out and let's look at number 1. This says f of x equals 2, where x is less than or equal to 1, and f of x is 3x minus 1, where x is greater than 1. So this first graph is going to be a horizontal line at y equals 2. So I'm going to go up at y equals 2, and I'm going to draw across. Does everybody see my horizontal line making? Doesn't matter what the x value is, the y value is up 2 on each one of these ordered pairs. That's made me a horizontal line up at y equals 2. Well, I don't want that entire graph. I don't want from negative infinity to positive infinity. I only want the x values where x is less than or equal to 1. Well, right here is x equals 1. Right down this vertical line right here, x equals 1. Now, I want the horizontal line to be showing, not all of this, but the horizontal line showing only for the x values that are less than or equal to 1. So I'm going to go to x equals 1, and this is going to be a closed circle because this says x is less than or equal to 1. So I'm going to close my circle, and then I'm going to draw this horizontal line not from negative infinity to positive infinity, but from negative infinity up to 1, and it equals 1. So this right here is my horizontal line, f of x equals 2, where x is less than or equal to positive 1. Now, if you want to leave this on here, you can do that. This red part shows what my graph is. So that's my first equation graph. The next equation says f of x equals 3x minus 1. Well, I know that that is a linear function. I'm going back to my origin. And my parent function goes right through the origin. It's an odd function, remember, going through the origin. Now, this negative 1 shifts me down 1, so I know my graph's going to shift down 1. This 3 in front of this x gives me a vertical stretch of 3. So my linear function, normally, I'm going over 1, up 1. But here, I'm going to go over 1 and up 1 times this 3 gives me that vertical stretch of over 1. Instead of being up 1, I'm multiplying times 3 to 3. Over 2, normally I'm up 2, but 2 times 3 is up 6. 2, 4, 6. Over 3, normally I'm up 3, but 3 times 3 gets me all the way up to 9. You see how my line's slanting? Now, for me to go the other way, I normally would go over 1, down 1, but I'm going to go over 1, down 3. Keep in mind that this line right here, this 3, that's 3 over 1. That's a slope of 3. That's a rate of change. Rise over run. This means for every x value that I go over 1, my y values change by 3. So every time I go over 1, I'm going up 3. For every x I go over 1, I'm going up 3. For every x I'm going over 1, I'm going up 3. I put that in the wrong place. So I should be over from here 3 and up 9. So I really should just be up to 8. All right, so there's my line. Now, this keeps going forever. It could go down 3 and over 1, down 3 over 1. Forever, both directions. But this says, okay, I only want to see the part of that graph, that linear function, where x is greater than 1. So I'm going to go back to x equals 1, and I only want to draw that line on the greater side of 1. So I'm going to take my purple pen and my straight edge, and I'm going to go over to x equals 1. On x equals 1, my line is supposed to be an open circle, but guess what? It's already closed right there. So closed overtakes open. So I'm going to connect my points, draw my line. So that's what this graph should look like. Instead of me seeing this entire linear function, I'm seeing the part of that linear function that is on the positive side of x equals 1. I'm going to leave the domain and the range for you on this one. We will talk about it on Thursday as well.